Hi everyone. So in today's or this week's module, we talked about correlation, and specifically we talked about Pearson's R, or the Pearson's product movement correlation. So that's a measure of correlation. It's very useful to determine the strengthness or the weakness of any of our variables and our different measures within our data. So when we were seeing them, we had the rule of thumb that if the dots are like your data dots on your graph are closer to the line in clusters, that it's stronger versus if it's like less clustered and less or more far away than to the line, then it probably has a weaker relationship. So the Pearson's R goes a step further and actually has a formula to determine what the probability of strength would be in the relationships. And so it's a little bit more reliable because it's using actual data and plugging it in and doing the math to determine this. So there's this big formula that we have, and it can be a little bit scary, but I'm gonna go ahead and break it down for you guys. So here's Pearson's R formula broken down for you. So beginning on the top row, you're going to have your number of observations times the sum of your product of paired scores, your x and your y, minus the sum of your x scores times your sum of your y scores. So that's how you will read it. And all of that's going to be divided by the square root of this bottom portion. So you have n again times the sum of your squared of x scores minus your sum of x scores squared. So make sure you have that distinction, times your n again times your sum of your y scores squared minus your sum of your y scores squared. Also remember the distinctions with the parentheses and the brackets. And all of that's going to help you determine your R. Okay, so hopefully that better helped you to visualize it and understand it better. Finally, I just wanted to go over some of the limitations for the Pearson's R. So to begin with, it is measuring a linear relationship. So if you have anything with any curves in your data, it's gonna make it close to zero as your R. So that'll greatly affect your data and your analysis, as well as it does have restrictions between variance and range. So if there's a higher range and higher variance, it's deemed to have a stronger relationship, versus if it's very restricted in its range or variance, then it's going to be deemed to have a lower strength relationship. And yeah, that's all that I wanted to go over. Hopefully this helped. Thank you.